You may have heard that Forth is a difficult, awkward, and out-of-date programming language used only by gray-haired old men. That's not true. I know there's at least one woman using it, and I've seen two young fellows use it as well. Forth works in the same way as a shell script, or any other language that has an interactive mode. If Forth is out of date, then so are Python and Bash. Using Forth is no more awkward than using an HP calculator. If you've ever evaluated an expression, you've been doing Forth without knowing it. Is it difficult? Ask the gray-haired men. If you want to add a new capability to the rover, you proceed in the same way you would as if you were writing a shell script, a BAT file or an SH file. So here I'll teach the forthmobile to look left and right by adding a new word called look left right. I'm using a homemade Forth IDE with some buttons to send left, right, forward, backward, and stop commands. If you type words at the Forth prompt, it will give you a list of words it understands, just like when you type ls or dir at the command prompt. You see them in the rightmost list box. Start with a colon telling Forth that you're defining a new word, then add the words that will be part of the new definition, and end the whole thing with a semicolon. Upload the definition to the forthmobile, and from now on it will have a new word called look left right. Okay, so in this video I'm going to try to show you how to build, program, and run a smart car using Forth as the programming language. I'll assume that you've read or at least skimmed Leo Brody's Starting Forth, and I'll assume you're familiar with the Arduino IDE. First, I'll mention some of the parts you'll need and some you don't, but that are nice to have. And then I'll quickly mention the software you need before going into details of the Forth code. So the smart car that I'm using is one that I've bought in parts from AliExpress. So you see it here. It's got 4 wheels. It's got a battery holder, and that's about it. On top of that, yeah, and the 4 motors, of course. Then you need a motor controller, and I'm using this one. The whole project is geared towards the use of this L298 driver. Then I'm using 3 sensors of the type VL53L0X laser sensors, and I'm using 1 compass, the QMC 5883. I've also planned to use a GPS module, but that's not part of the project as per now. Then the system runs ESP Forth, running on an ESP32, so you need one of those modules. And then to connect everything together, I've designed a board here that where everything can just plug in, but you can design your own board, or you can go and check out this one on GitHub. I'll give you the links. And then you'll need the Arduino IDE, and you'll need the ESP32 extension to the Arduino IDE, and then you'll need an ESP32 file system uploader. This is because you need to add some Forth code to the ESP32. So here are the 3 files that will get you going. First, you need to configure the forthmobile as an access point. Then you give it an ID and a password, and then you start a telnet server. There are other servers that you can start, one for HTTP, but I'm using telnet because of the way it's easy to integrate with a client. Uh, then is for controlling the motor driver. So first I define some pins to be used, then some constants for direction, forward and backward. Here's the code to initialize the motor. I'm setting pin mode, which you might recognize from the Arduino IDE. Um, and Here I have some words to set the speed on the left and right motors. One to set the same speed on both motors. And this one, very important word, to stop. And here's how to manipulate the gears. So I can set the left gear forward, backward, and the right gear forward, backward, controlling the two motors individually. And then I have one that controls both motors simultaneously to drive either forward or backward. So I send the same command to both of them, and I give a PWM value, a speed value. Then it can turn on a dime, so it sets the motors to go in upright in opposite directions. And then I initialize the motor, and from then on you have access to all these words. Now the last file is the most interesting, because that's the one that lets you find your way around the living room floor. So it defines some constants again, and here it takes care of the left and right PWM value, because the car will not drive in a straight line. The motors, if you give two motors the same PWM value, they will still run at different speeds. So there's a little word here that reads the compass, and then it subtracts that from the course you run. And if there is a course error, it will correct it. So it will veer either to left or right by updating these left and right PWM values. And here it will decide on what to do when it finds an obstacle. Either it will back up, or it will turn right or left, depending on whether or not there's an obstacle to the left or to the right. And when it's boxed in, then it will stop. And that means if all the sensors show that we're closer than 20 centimeters to something, then it says we're boxed in and it stops. This is for demonstration purposes only. In your own code, you would have it back up, engage the servos to try to find a way out of that corner or whatever it was you boxed yourself into. And this is the main loop. It reads the sensors to have initial values. Then it initializes the left and right speed, and then it engages the gearbox. And then there's a loop that plots a radar value to that you can use if you have a smartphone IDE that I'm working on, but I'm not quite finished with it yet. It reads the sensors, corrects the course, decides what to do until it's boxed in, and then it's finished.
Han tilbyr deg en syk. Synes du er slik? Skal du
Is Ford cool or what?